Thank you for joining this lesson. We're going to discuss sequences and series. We are told that in number 18 that the first, the 7th, and the 25th terms of an arithmetic progression are the first three consecutive terms of a geometric progression. The 20th term of the arithmetic progression is 22. Find part A, Roman 1, the first term and common difference of the arithmetic progression. Therefore, we are given some conditions here that the first term, which we would call A, then the 7th term, which is now going to be given by first term plus, because nth term is given by A plus n minus 1 multiplied by D. Then it means this 7th term now for the arithmetic progression will be 6 multiplied by D, and the 25th term, which will be A plus 24D, they form the first three terms of what we call a GP, geometric progression. So it means the first, the 7th, and the 25th are consecutive. Now that they are consecutive, it means they have a common ratio. There is a common ratio relating them. So when we take, because they are in this order, therefore when we take the second term, A plus 6D, out of the first, it will be the same as taking the third out of the second, because there is a common difference relating them. There is not a common difference, but a common ratio for this case relating them. But again, there is another information to be interpreted in this case. We've been told that the 20th term is 22. The 20th term is 22. So it means the value of 22 is given by A plus, when we take 20 minus 1, then we multiply by D, we get 19D. So A plus 19D should give us the 20th term, which is 22. And from this, we can express A to be equal to 22 minus 19D. 22 minus 19D. Let us first of all expand. We can cross multiply in this case, A times this part, and we're going to have A squared plus 24 AD. This is equivalent to, when we cross multiply this side, I'll get A plus 6D squared. And this will give me A squared plus 12 AD plus 12 AD plus 36D squared. 36D squared. Therefore, we can group like terms together, whereby A squared disappears because it is appearing on both sides. Then we will have 12 AD after subtracting 24 and 12. This will be equal to 36D squared. 36D squared. So we can divide through by D, which is appearing twice, and also by 6. Therefore, 6D is appearing twice. Not even 6D, but 12D. So we can remain with A being equal to, when we divide by 12D, we're going to remain with 3D. So the value of A equals to 3D according to this second equation, because there is a first equation here. The value of A in the first equation is given by 22 minus 19D. And the value of A in the second expression is 3D. So we can equate the two sides. Now that both sides are giving us A, then we can conclude that 3D is equivalent to 22 minus 19D. That means we can take 19D to this side, whereby it will be added, and we will find that 22d equals to 22, and the value of d is going to be 1. Then now we can solve the value of a, which is equivalent to 3d, and the value of a is going to be 3 when we multiply the value of d by 3. Therefore, these are the first terms and the common difference for the arithmetic progression. We've been told again in the same question part 2 to find the sum of the first 40 terms of the arithmetic progression. Remember, the sum of a given number of terms is usually given by n out of 2 into 2a plus n minus 1 multiplied by d. Therefore, for 40 terms, we'll start with 40 out of 2 into 2 multiplied by first term, which is 3, plus n, 40 minus 1, multiplied by the common difference, which is 1. Therefore, we're going to have 20 into 6 plus 39 by 1, which is 39. Therefore, this is going to give us 45. Yeah, that is 39 plus 6, 45 by 20. 45 by 20, giving us exactly 900. Exactly 900. We can also talk about the same can be approached by, first of all, getting the 40th term. The 40th term, this is alternatively, the 40th term will be given by first term 3 plus n, which is 40, minus 1 multiplied by d. So this is going to be 3 plus 39, because d is 1. This is going to be exactly 42. Therefore, 40th term is 42. If the 40th term is 42, the sum of n terms can be given by n out of 2 into first term plus the last term in that progression. Therefore, 40 out of 2 into the first term, 3, plus the last term, 42. And again, we are multiplying 45 with 20. This will automatically give us 900. 900. We can also solve another part here, part B, whereby we are told to find the 10th term of the geometric progression. For us to get the 10th term of the geometric progression, it means we will need to first of all know the first term, which is 3. Then the second term now becomes the 7th. For the GP, 7th term in the AP becomes the second term in the GP. Therefore, A is 3 plus 6. This becomes 9. So the term here is 9. Then the third term is going to be the 25th term, whereby we will have the first term 3 plus 24 by D, which is 1. So plus 24, this is giving us a 27. Therefore, the common ratio for this GP is going to be either 9 out of 3, which is the same as 27 out of 9. This is giving us 3. So the common ratio is 3. The first term is 3. Therefore, 10th term. We should know that nth term is usually given by a raised to r power n minus 1. This means the first term 3 multiplied by the common ratio of 3 raised to 10 minus 1. So the 10th term is going to be 3 times 3 raised to 9. 3 times 3 raised to 9. So 3 power 9 then we multiply it by 3. The term is going to be 59049. That is going to be the 10th term. Then now we want sum of the first 10 terms in the last part. The sum of the last 10 terms. When the value of r is greater than 1, the sum of a given number of terms is given by a into r raised to n minus 1 divided by the value of r minus 1. Therefore, we're going to have the first term as 3 into r, which is 3, raised to n, which is 10. Then we subtract 1, divided by 3 minus 1. Therefore, we're going to have, I'm just going to work it out once, 3 power 10, then we less 1, then we multiply this by 3, and we divide by 2. This is going to be 88,572. So this is going to be the sum of the first 10 terms in the geometric progression. Thank you for following. Subscribe and share.